Absolutely. So exercise number 25 and 1.4. Let's do that. And I forgot my book, so give me a minute while that's loading. I'm gonna grab my book and I'll be right back and we'll do that problem. Okay, so 1.4, number 25. That's on page 31. So I have, just make sure it's the right one. We have y minus 2xy equals 15, x equals -1. Is that the right one? All right, so let's do that. It doesn't like when I write dots for some reason. 1.4, number 25. Y minus 2xy equals, make sure I write it right, 15. Okay, so first we have to solve the equation for y, right? So this is one of those tricky ones where there's y in both terms, right? But they're not like terms, so we can't subtract them or add them together, right? So what we're actually going to want to do in order to get the y's together is we're actually going to want to pull y out of both of the terms, all right? So if we do that, we're left with y 1 minus 2x. So we pull a y out of y and you're left with 1, and we pull a y out of 2xy and we're left with 2x equals 15. Okay, and then what this means is that we actually have something times something. It's my technical mathematical term, right? We have y times whatever's in the parentheses. So it kind of feels like awkward that you're able to do it. Yeah, you got it. But you're actually allowed to divide both sides by everything that's in the parentheses. Yeah, that's the trick to this one. And these actually cross out. It feels awkward that you're allowed to do that, but then you're left over with y equals 15, 1 minus 2x. Yeah, I know. When I looked at it, I was like, oh yeah. But I've been doing it for a little bit, so, and it is my favorite property. All right, any other questions you wanted to go over? All right. Well, what I was going to do today is kind of introduce chapter 2 a little bit, because I think it's helpful to go over this big concept, because it's kind of a big concept in Algebra 2. So it doesn't hurt to see it, and then we'll probably see more of it on Monday, and then we'll start off on chapter 2. So you don't actually have the notes yet for chapter 2, which is okay. I'm just going to kind of talk about what we're going to talk about here. And I have the notes to pull up, but I'll hand them out on Monday. All right. So Sarah, have you heard of a function before? Okay, awesome. So in algebra, specifically Algebra 2 and pre-calculus and calculus, um, we like to talk about equations, and we also like to talk about functions, which functions are a specific type of a relationship. Okay, so we have these things in math called functions. And the first thing I want to talk about is how and what is a function. Okay, so a function is when you put something into a function. So let's just call it like this weird red box. Okay, and this is your function. Fun. Oh, there's a fun in function, so it has to be fun, right? Function. All right, so the idea of a function is you put something into the function, okay? And then there's always exactly one thing that comes out. There's always one output. So you put something in to your function, and there's exactly one thing that comes out. All right, an example of a really super simple function, let's say, would be, and we'll talk about the funny f of x thing here. Okay, so usually what you put in a function is your x's. That's usually what we call the domain, what we put into our function. And what we get out is y. Because usually what we do in algebra, right, you put in some x and you get out some y. So we're going to stick with that, thankfully, for our function notation. Okay, and let's say I put, in this particular function, I put the number 3 in, right? It goes through my function. My function is 2 times x, and that's what I put in. So it would be 2 times 3. So it goes through my function, and out pops 6. All right. If I put in the number 1, right? I put 1 in my function. Goes through my function. 2 times 1 is 2, and it pops out 2. So the idea behind a function is it's just something that is a relationship between an input and output, right? And for every number that you put in, this is what makes a function important. You can only have one value that comes out the other side. All right, so if I put in x equals 3, I have to get one particular value that comes out. I can't get x equals 3 and my function is 6, or maybe it's -6. That would not be a function. So it's just basically a way of describing a relationship where everything you put in has exactly one thing that you get out. Okay. The other thing with a function that I already kind of wrote on here, is this what you use for finding points on a line? You may have used it for that, yeah. So it's kind of familiar in the back of your head there. There. Yeah, so the other thing with function that kind of, when people first see it, and if you've seen it before, Sarah, it may, whatever, might not be such a big deal, is this idea of how do you actually write a function? So you kind of saw me sneak this in here. But when we have something, when we have an equation, we use y and x, right? When we use a function, we use something called function notation. So let's say our equation was y equals 2x plus 3. If we wanted to write this as a function, we would write this as f, a function of x, equals 2x plus 3. All right, so people always get a little like, ooh, what is this f of x? Why is this weird? In your head, you can kind of think of it like a y. It's what you get out of the equation. But because this is a specific type of an equation that has some specific rules about it, we have a separate name for it. So we say f of x equals 2x plus 3. But it kind of works in the same way, right? Your x is what you put in, and your f of x is what you get out. Just like your x is what you put in, and your y is what you get out. Okay. There's some other kind of names that are associated with this, the in and the out. So your x, what you put in function world, right? It's like its own special land, has a special name, which is the domain. So the domain is what you put in. It's usually your x value. So if you've ever heard that before, what is the domain of this function, or what is the domain of this equation? It's talking about what you're putting in, okay? And what you get out is called the range. Okay, so we started, it's like a bunch of different words here, right? But it's really not too complicated when you're actually looking at it. So let me clear this off a little bit. And this is why I think it's helpful to do today and on Monday, because it's just like hearing it a few times and you're like, oh, okay, I got it. So let's talk about a really simple, function, okay? So remember, my x is my domain, okay? And I am going to look at this function over a very specific domain. I'm going to say the domain for my function is 0, 1, and 2. Okay, and then I'm going to do a very simple function, f of x equals, we'll do x squared. Okay, so my output, when I put x equals 0 in, that basically means that I'm saying, what is my function when x equals 0? So when x equals 0, it's 0 squared. So when I put in 0 in my function, my output, my range is 0. Okay. When I put in 1 in my function, I do 1 squared and I get 1. And when I put in my domain of 2, my input is 2, I get 2 squared, which is 4. So if I wanted to map the domain and range of my function, the domain, I would say, is 0, 1, 2. And the range is 0, 1, 4. And they would be matched like this. 0 matches to 0, 1 matches to 1, and 2 matches to 4. All right? Super duper exciting, right? It's kind of just a weird terminology, right? Now, if I added another point to my domain, so this is kind of, if I added 3, and you know what 3, I'm sure you know what 3 is. But I added 3 and I said that when I put 3 into my function, I could get 6 or I could get 9. Okay, so I add 3 in and I could get 6 or 9. This, all of a sudden, this orange addition down here makes this not a function. Because for everything that I put in the domain, everything on this side has to match up with only one thing in the range. So if I have something that matches, well, for this particular case, You're right. I couldn't get 6. But if I just gave you some random domain and ranges, we couldn't match up to more than one number. In this particular case, you would get 9 and it would still be a function, right? But I'm just saying, if you just had this set of data without knowing what the function is, and they said when you put in 3, you could get 6 or 9, then all of a sudden that's no longer a function. There's this one-to-one relationship. Yeah, sorry, that was a little bit confusing how I explained that. Okay, so one other thing that's kind of interesting well, as interesting as you can get about a function, right? Is let's actually use one more value that can be true. Okay, so what if I put -1 in my function? So -1 squared is +1. So we know this orange one is out, right? That makes it not a function. But what if we add -1 in here? I should have left a little room. If I add -1 in my domain, my output, my range is actually +1. And this is allowed in a function. So the green is okay. The orange is not okay. All right. So you can put in -1 and get +1, or you can put in +1 and get +1. So they're allowed to share values in the range. It's just that if you put in a number, you answer. Yeah, it is a little goofy. I'm glad you like it though. Well, it's kind of just like a set of rules that govern the world of functions. Okay. So you put a number in and you could end up with the same number as something else. But if you put a number in and you get 2 different answers, not a function anymore. Okay. So that's my introduction to functions. I'll do more about functions on Monday, but I know you have your chapter 1 homework and tests to work on. So I really wanted to make sure that everybody had time to ask any questions they might have. So that's it, Miss Sarah. Thank you for joining me today. Unless you have any other questions or you want me to, go over anything with functions, but like I said, we'll go over it some more on Monday as well. See, you get it. It is function. All right. Well, I'm glad that you joined me, Sarah. And hopefully everyone else gets a chance to listen online, and we will talk on Monday. All right. Thank you very much. And let me know if you have any questions once you get to the test or anything like that. Thanks.